This video is a review of how to complete the square. Understanding what it means, first of all. Completing the square, the whole goal here is to write a quadratic in the following form: y equals ax squared plus bx plus c. And we want to convert it into a quadratic that looks like the bottom standard form, which is a times the quantity x minus h squared plus k. So remember, h and k are key indicators of how to graph the function. So if we can write a quadratic in this form, we can graph it a little bit more swiftly. We can also solve for missing information a lot quicker as well. So first we're going to just talk about how to do it and how to rewrite these equations and what it takes to do that. So let's take a look at the first example. So I kept the goal up there because I think it's important to see where we're headed and why we're doing what we're doing. We have the form ax squared plus bx plus c, where a is 1x squared plus 16x minus 15. So the key here is to look at your x terms. Okay, they definitely are a key part in your thing that's being squared. So basically this thing right here, x squared plus 16x plus something, I want to be able to write that as x plus something squared. And these somethings are different, but they're important information that I need. So first of all, it's really important to be very familiar with how to square things. So for instance, if this was x minus x plus a squared, let's call it x plus a squared, we need to know quickly that the product is x squared plus 2ax plus a squared. Okay? That's a key product that we've talked a lot about in class, and it's really important that you know and are quick with. If you don't know that, then draw your generic rectangle, work it out, show yourself that this is true. So take a look at the goal. If this is a perfect square, then the 16 would be this term here. So what would a have to be? And that's the first step to solving this and finding the perfect square. And the perfect square in this case, a would have to be 8. Because the only way for us to get 16 is if we double 8, because this is 2 times 8. So the way we always get our extra term for our perfect square is to divide this by 2. Now, here comes our dilemma. Our dilemma here is the original problem had minus 15. That's still a part of my problem. I'm leaving it out of my parentheses. It's going to impact the k term that you see up here. But in order to create a perfect square, I needed to figure out exactly what this value had to be here for this 8, and it has to be 8. But what happens now is that there's this extra term a squared, this term right here that we didn't know to begin with. That term in our case has to be 64. Now you're thinking, we don't have 64. Where is this coming from? Well, it's coming from the fact that this thing will create 64. And this is the only way to get a perfect square that has an x squared and a 16x. So I have to have this as my perfect square. I definitely know h is going to be negative 8 based on this information. But the issue is the 64, well, I don't want that there. So to accommodate that and make sure I don't change the value of anything, I subtract 64 on the outside of my parentheses. That way I've not added anything or subtracted anything. I've actually just put stuff on the board and taken it off later. So this is equivalent. So let's take a look at what we have here. This value that we see here, all the way to the end, is equivalent to the original. It has x squared, it has 16 x's, and it still has the minus 15 because this 64 and this 64 cancel each other out. Okay? Now, moving down. This value right here, in order to make it equal, well, I know this is equal to this, but now I need to rewrite that a little bit simpler. So that can be written as negative 79. Now I can claim the following, that this value here is equal to this value here. And of course that means it's equal to the top one up there. So these are all equivalent statements. So I've actually met my goal on how to go from a quadratic to a standard form. So let's review the steps that we had to take. So we first had to take this and think about the fact that only these two terms will appear in my perfect square. So that helped me because from the 16, I simply divided by 2 to get my h value the h value that goes in the perfect square. Now, how do we get this value? Remember, it's simply just h squared, the number that went inside my h here, or in our case down here, a squared. So these are two important steps, but the final step is I need to actually take off the h squared over here in order to make sure I didn't change the value. So there are three major steps here that you have to follow. Okay? You find your h value by dividing b by 2 to get your h. And the second thing is we take h squared to get the value that we have to subtract, the extra value that we see here. Okay, that's the value that we have to subtract off at the end. Let's try one more example with an extra twist, okay? Because if you did not notice the important piece up here, there was no a here. There was no a value. The a value was non-existent. It was a single one, so it didn't really matter. We're going to see one more example where it does, and we'll talk about how that influences things. So here's another example. Write the quadratic in the following form. So once again, we need to factor and make it so it's a perfect square. We still start by looking at our x's. Okay, but what's different here is we need to factor out the 2. So we're factoring out the 2 and rewriting this as the following. Okay, so far my two values are equal. The top line is equal to the bottom line. Okay, because I still have my 2x squared minus 18x right here, and then I still have my minus 15 over here. Okay, whatever this value happens to be, we'll figure that out in just a moment. I will make sure I subtract it off back here. Okay, so let's go through our steps again. The 2 just hangs out up front. We'll see how it impacts things in just a moment. So remember, your goal is to write this as x minus something. Okay, in this case, I know for sure it's minus because my first step is to divide this by 2, and I get 4.5. Remember, that is because we want the following. We want, when we square this, we'll get 2 times 4.5 x plus 4.5 squared, and that's from our important products. Okay, multiply this out to make sure that you believe me, this is equivalent. So we're at this point where we have our b value. Now, we think about what this value right here would be. Well, that value is going to be, like I said here, a negative 4.5 squared, or just 4.5 squared, and that is 20.25. So that's my extra c value here that I am including because I want to make it a perfect square. So now we have the case where we need to make sure our values stay equal. So we've introduced this term right here. We have to make sure we subtract off enough over here so we don't change the value. Here's where our 2 is impacting it. So 2 causes this value to get doubled. So I need to make sure I subtract off double. So off of the end over here, I actually need to subtract 40.5 so that it will impact it. So once again, the good news is you can check your work as you go. So if I work this out and I multiply this 2 out, and then I subtract 15 and I subtract 40.5, I should get the same exact value as you see up here. Okay, you should have the same exact values you see up there. So make sure that you check that if you don't quite believe it. Now I'm going to continue rewriting it as the perfect square in the standard form. So we have this form right here. We have it already started. Now remember, it's minus 4.5 because of this minus 9x. And then we're going to simplify this to be a minus 55.5. And we have our equation. So now our equation is y equals 2 times the quantity x minus 4.5 squared minus 55.5. In the upcoming sections in class, you'll be seeing more about how to graph these a lot quicker so that you can solve these problems. But remember, you can always check it as you go. You can even graph all these equations and it should be the exact same parabola. So take a look at a few problems that you can try. So these are a little different than what we were doing, but basically you're trying to figure out what it is that number should be so that you could write this as x plus something squared. What would c have to be? Okay, so play with that, bring in questions, make sure you remember how to do this from Algebra 2.